everybody, it's me, Miss Phoebus, and this is lesson 14, graphing functions on a coordinate plane. Goal for today's lesson is I can graph a function given specific domain values, or by creating a table, I can make a table given a graph of a function. So it's all about graphing. And then here are our standards, where the yellow is what we're really focusing on, graphing equations with two variables on coordinate axis with labels and scales. And so that is, for some of you, maybe something you have to draw if you are not printing out graph paper. And it's okay to not print out graph paper by hand. I don't know why I have Ann using technology right now, because we are going to be using technology later, but it's definitely by hand today. All right, so we're going to start with this graph by making a table. Notice that my graph here is blank. And so if a graph that you have is blank, it is assumed that each individual marking is 1. If I wanted to kind of make this to where I could reach larger numbers, I might include some other numbers to show what I'm counting by. And so that is a possibility if you are using very, very large numbers. I'm going to use these as 1 counts, so you don't have to worry about that for right now. But this is my x-axis, this is my y-axis, and that really just helps orient the position of the graph so that people are looking, how are they looking at it. And I recommend you do that because sometimes when I pull in your pictures, it turns it funny and so it'll put it upside down. There's one kid that your paper always gets turned upside down, and there's ones that are always, on the left or on the right, they're rotated, and so I have to rotate them. So this is something that's very helpful to me. If you would please label your axes, I would greatly appreciate it, especially when you're taking a picture. Now I know that you know how to graph, or you should be familiar with graphing a line in y equals mx plus b form. That's not the point. The point right now is to get you used to what I'm asking you to do, which is make a table of values. So this kind of goes in with our evaluating functions, where we're going to plug in some things. So we're going to make a table of values. And what I want you to do is I want you to plug in 5 points, 5 x values. Now, right now we're going to choose a certain select set, but in the future and what we're going to do, I'm going to say, these are things that you can choose to do on your own, but we are going to choose 2 negative values, 1 value that's 0, and then 2 positive values. Okay, so because I am just doing all of these examples, when I get to where it's like, oh, you can choose whatever you want, I'm going to still have to be choosing. But it's something that you do have the freedom to do. But I want you to do 2 negative numbers, 0, and 2 positive numbers. So I'm going to pick 2 negative numbers, and I'm going to keep them pretty small. You don't want to go too crazy with these because you are plugging them in and you're going to get a different answer. Now what we're doing is we're using a domain. We're going to plug that domain in for x. You're going to use the order of operations, and then you're going to get a y value, and then that is going to create a point. So I'm going to look at plugging in -2. So y equals -2 times -2 plus 1. -2 times -2 is 4. 4 plus 1 is 5. So my y value is 5. Now, some of you can do that in your head. Some of you will plug it in a calculator. That's fine. I'm not quite, that's fine. I'm not going to be picky about how you get your y values right now, but I do want you to be doing something to get them. Now let's plot this as a point. -2, 5. You go to start at 0, 0, of course. Don't make that a point. But start at 0, 0, and we're going to go left 2 and up 5. 1, 2, 3, 4, 5. So right there, we're making a point. All right, let's try -1. So -2 times -1 plus 1. -2 times negative 1 is 2. 2 plus 1 is 3. So negative 1, 3. So we're going to go left 1, up 3. We're going to put a point, and that is the second point on my graph. So I want 5 points. Let's plug in 0. I'm going to not be writing y equals, but I know that what I am getting is a y value. So negative 2 times 0 is 0. 0 plus 1 is 1. So 0, 1. All right, let's plug in 1. Negative 2 times 1 plus 1. Negative 2 plus 1 is negative 1. So I've got 1, negative 1. Then our last one, and then we'll connect the dots. 2 times, negative 2 times 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So 2, negative 3. Oh, I went down too far on the last one. I was like, this isn't right. And that's what happened. Okay, so I have my table. My table is needed for my grade. I have my graph. My graph is needed for my grade, but my graph is not done. Even though we talked about discrete and continuous functions, anytime you are just given an equation, there is no situation that goes along with it. It is automatically continuous. So what we're doing when we're creating this line, and we're going to make sure our line goes all the way across the coordinate plane. No dinky lines, no little tiny lines. If you draw a line like this, just know I'm sad. Okay? Don't draw sad lines. Draw lines all the way across the plane. That's going to come in handy later when we get 2 lines on the plane and we're trying to see where they cross. Now, for those of you that know slope-intercept form, your y-intercept is 1. So look there, it's crossing the y-axis at 1. It's got a slope of negative 2, so we're going down 2, right 1, down 2, right 1. So our line is looking good. But the thing is that we're going to be graphing some other things that you've never graphed before. We're going to be graphing some quadratics. We're going to be graphing some absolute value graphs. We're going to be graphing some cubics. And you don't know about these yet. You don't know their names. You don't know what they're supposed to look like. But if you can go with the 5 points, 2 negative, 0, and 2 positive, plug them in, and you're doing the order of operations correctly, you're going to be able to do this with a table. Doesn't matter what the function looks like. And this is a great skill to have, especially if you get some weird function you've never seen before. You're going to be able to graph it by plugging in points. And so that's the skill that I'm trying to get you to do. All right, so let's look at number 2. These aren't numbered, but number 2. So we're going to be plugging in 5 points. I'm going to be, again, you want to try to stay, at least right now, close to the y-axis because these numbers, especially when I start squaring things, they're going to get really, really big and they're not going to be able to fit. So like if I take 9 and square it, I've got 81. And so I've got something really huge that I haven't even multiplied by 3 yet. So remember your order of operations. I've picked negative 2, negative 1, 0, 1, and 2. They're really great values to choose. Not always the best values, but usually those are the ones that I recommend choosing. So let's look at plugging those in. Now remember when you're plugging in negatives, especially when you're squaring them, you need to wrap them in parentheses. If you feed that into a calculator without parentheses, you're going to get a wrong answer. So we're going to do exponents first. So 3 times 4 plus 1. 3 times 4 is 12. 12 plus 1 is 13. Now 13 is not going to fit on this. I think the very top line is 11. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 will not fit, but if I skip count and do 2, 4, 6, 8, 10, 12, 14, 13 will fit. It'll be an in-between place right through here. Okay, now you can keep this as negative 1, negative 2, negative 3, negative 4, and 1, 2, 3, 4 if you like. But you know, it's one of those personal preference kind of things, and then you also have to show that on your graph. If you are counting by twos on the y-axis and you want to count by twos on the x-axis, you can do that. You can write me a little note that says counting by twos as scale. Okay, so then that way I can know what's going on. You have several options. I usually like to go ahead and number. So if I'm going to keep my x values as, you know, ones, and then my y values as counting by twos, -2, 13 is right about there. All right, let's do another one. Let's plug in -1. And remember, this is just order of operations. So -1 squared is 1. 3 times 1 is 3. 3 plus 1 is 4. So now I have -1, 4. And usually I like, especially if I have my numbering in like pencil, I usually like to come through and do a different color just so that the graph stands out from the numbering. But try to stay neat. All right, let's try 0. 0 squared is 0. 3 times 0, well, that's 0. 0 plus 1 is 1. So we've got 0, 1. So that's this halfway point, because remember I'm counting by twos on the y-axis. And then let's do 1 and 2, and then we'll draw our picture. So 3 times 1 squared plus 1. Well, that's 3 times 1, which is 3. 3 plus 1 is 4. Remember, the table is part of your answer. 1, 4. It also allows me to see, are you plugging in the right numbers? What numbers are you plugging in? Are you graphing points right? All of those things that table allows me to see. All right, so now I'm plugging in 2. So I've got 3 times 2 squared is 4. So I've got 12 plus 1. I have another 13 on the other side. So 2, 13. And you could keep going. If you pick a number that's way too big, you might want to reevaluate what you're doing with your x's, what you're choosing. We end up with a little curvy, almost like a smiley face. A little curve there. That's one of our families we're going to learn about on Friday. Okay, but you've never graphed this before, and so you don't know what it looks like to graph. You pick 2 negatives, 0, and 2 positives. Let's get another one. Actually, I think the next one's a you try. So pause the video, see if you can do this graphing and make a table. All right, I'm gonna make my table in red this time. Now, this is one where it might not look too great if I do these, but we'll see how it turns out. So I'm going to plug in, and you can always add points. Always add points. We're going to plug this in, and we're going to do our parentheses, the stuff inside, and then we're going to square it. So -2 plus 1 is -1. -1 squared is 1. So -2, 1. And then we're going to do the same thing with 1. So, I'm sorry, -1 plus 1 squared. Well, -1 plus 1, oops, sorry. -1 plus 1 is 0. 0 squared is 0, so -1, 0. And then let's do 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. 2 plus 1 is 3. 3 squared is 9. I think all of those will fit on there. So I've got 0, 1, 1, 4, and 2, 9. Okay, so I feel like I have more on this side that I feel like I could connect the dots with. I don't feel like I have enough on the left side, so what I can do is I can put in another number, like -3. Let's look and see what happens with -3, and let's see if I can get another point that allows me to feel better about graphing this. This is negative 2 squared. Negative 2 squared is 4. So negative 3, 1, 2, 3, 4. So that feels a little bit better. And then I can graph it. So how'd it go? These are more curved than straight arms, because if you do straight arms, you might end up trying to do like a straight arm piece here, a straight arm piece here. So you don't really need to do that. You need to do these kind of curvy pieces, but we're going to get better at those. So if yours are straight, that's okay. All right, let's try another one. Okay, we're going to make a table. We've got cubes. We're cubing things. You know what that means, right? We're taking something and multiplying it times itself 3 times. X cubed is x times x times x. And there is not a cubic button on your calculator, but you could put something in, well, you know, you could use the caret and then the 3. And that would be a cube if you're putting it in the calculator. Or you could just do 2 times 2 times 2, 3 times. All right, I'm going to do negative 2, negative 1, 0, 1, and 2. And I'm going to look at negative 2 cubed, which is negative 2 times negative 2 times negative 2, and that is negative 8. So negative 2. So down here, negative 2, negative 8. And then let's do another one. Let's do negative 1 cubed. That's negative 1 times negative 1, which is positive 1, times negative 1 is negative 1, so negative 1, negative 1. And then 0 cubed, 0 times 0 times 0, that one's easy, that's 0. 0, 0. 1 cubed is 1 times 1 times 1, which is 1, so 1, 1. And then 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 2, 8. So there we go. And then if we get into 3 cubes, we're getting into 27. So that's too big. But you kind of have this curve that goes up like this and try to hit all your points. And kind of goes down like that. And then just know that all of these, the line is kind of covering all these little tiny points that you could be plugging in. We could plug in 1.2 and 1.25 and get all of these different values. The line is taking care of it so that I don't have to graph each individual one. So a line is a collection of a whole bunch of little tiny points. All right. Now, here is one where 2 and 3 are not going to be the best numbers. So I have 2 minus the square root of x. So what I want is I want to put numbers, pick numbers where the square root is nice. And I'll go ahead and tell you there are no negative numbers. You cannot take the square root of a negative number. It doesn't work. So we're going to still try to find 5 numbers. So we've got x and y. Let's see, one of the very nicest square roots that I can take is 0. The square root of 0 is 0. Then I can take, that's a 0. And then I can take the square root of 1. So 1 is also a nice number. The square root of 1 is 1. But the square root of 2 is not nice. It's irrational. It has a decimal that never ends. So we're going to skip 2. We're also going to skip 3. But the square root of 4 works. Not 5, not 6, not 7, not 8, 9 will also work. And the next one is going to be 16. And I think 4 is good enough. So what we're going to do is we're going to plug in 0, 1, 4, and 9. And so this is where you have the freedom to choose numbers. You want to pick the ones that are best for your situation. So the thing is like if you've got a fraction, you might want to, like if I had a fraction 1/3 x, I might want to pick things that are multiples of 3, like 3 or 6 or 9 to plug in for x, because then I don't have to deal with fractions anymore. I have nice numbers to work with. So you are allowed to pick the values. On square roots, though, no negative numbers. So let's look at this. 2 minus the square root of 0. Well, the square root of 0 is 0. 2 minus 0 is 2. So 0, 2 is a point on my graph. Let's graph 2 minus the square root of 1. Well, the square root of 1 is 1. 2 minus 1 is 1. 1, 1. It's on my graph. All right, let's do 2 minus the square root of 4. So 2 minus square root of 4 is 2. So 2 minus 2 is 0. That's out here at 4. 4, 0. And then the last one, 2 minus the square root of 9. The square root of 9 is 3. 2 minus 3 is negative 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 1. Now, I can't use any of the numbers that are negative. So basically, this is off limits. You don't have to draw this in your graph, but that's off limits. So 0 is the smallest number I can use, because 0 is the smallest non-negative number. So I've got something that kind of looks like that. But that's for square roots. You don't come across them too much in Algebra 1, but I did want to show you that it's something that you can graph. So just remember, you don't have anything in negative territory because you can't take the square root of a negative number. And if you do want to try to do that, put it in your calculator, see what happens. Calculator won't do it. Why should we? All right, you're going to try this one. Make a table of values. All right, I'm going to make a table, X and Y. This one I would recommend some negatives, some positives, because you want to be able to see both sides of this graph. There's actually a change that happens here. And so I do want to show you with the negative. The absolute value of negative 2 is 2. 2 plus 2 is 4. So negative 2, 4. 1, 2, 3, 4, right there. All right, let's try negative 1. The absolute value of negative 1 is 1. 1 plus 2 is 3. So negative 1, 3. Let's plug in 0. The absolute value of 0 is 0. 0 plus 2 is 2. So 0, 2. Now we're going to do the absolute value of 1, which is 1. 1 plus 2 is 3. Now, if you only did positive numbers or 0, you wouldn't see the bend in this function. So absolute value of 2 is 2. 2 plus 2 is 4. So there is a benefit. I'm going to go ahead and connect my dots. There is a benefit of doing 2 negative, 2 positive, and 0 for the most part. And then if you feel like one side there's not enough points on it or something like that, you can always go out and get more points. How'd yours turn out? Does it look like this, or does it just look like one side of this? If it just looks like one side of that, you're going to want to maybe explore the other side. And if the other side kept going down, then you might be good. But the other side goes up, does something different. That's interesting. And you would want to get that on your graph. All right, so here is a graph, and you're going to be making a table of values for that graph. So in your table, you want to label that X and Y. You could label it domain and range if you want to, input, output, but usually X and Y is the way to go. And what we're going to do is we are required, looks like about 4 values to list. And so it's just, can you go through and tell me what points make up this graph? Now we only need 4. So it looks like 0, 0 is on this graph for sure. We don't have any scale, and we're really dealing with something that's not labeled either. But if we are counting these by ones, that's what we're going to do this time. So we're going to have 1, 1. And then this point out here is 1, 2, 3, 3. We want to use points on the graph. And then let's say this is negative 1 and this is negative 1. So negative 1, negative 1. Okay, so you're just looking at the graph and pulling out some values. All right, so this one looks interesting, but I do see some different points. I see a point here that's nice, and here, and here, and here. These are all nice points that are given to you, but this is also a nice point. This is the y-intercept where it crosses the y-axis. That is a nice point right there. It looks like I can tell what that value is. Here, where it crosses the x-axis, it's not quite probably have some sort of equation to plug it into. You actually have 1, 2, 3, 4, 5, 6, 7 nice points, and really you have an eighth nice point that's not marked as a point. So you could have any of these points. So you could have, let's see, 1, 2, again, we are assuming that these are ones, 1, 2, 3, 4, so -4, -1. You could also have -3, -1. You could have -2, 1. You could have -1, -5, you could have 0, -4, you could have 1, -3, you could have 2, -4, or you could have 1, 2, 3. Oh, we do have a scale there. 1, 2, 3, 4, 2. Okay, so